Welcome to Contextual Electronics. My name is Chris Gamble, and today we're going to be talking about the ABC board, which is a board that we've been working on as part of the Contextual Electronics course for about 5 months now. Maybe even longer. Wow, 6 months. I guess it started in May, and so we've been posting regular updates about this board over on the course. It is a paid course on contextualelectronics.com. There will be some free content coming out about it in the near term, but I wanted to explain what it actually is and why I'm building it in the first place. So the ABC board stands for Advanced BLE Cell, which is a terrible name, but is something that that I knew it was going to be an advanced board, and it does have Bluetooth and cellular on it. That's really the idea here. And so one thing I wanted to do was make a platform for myself, because I found myself making cellular boards over and over again, and it just kind of felt silly. Right? It should be like I should be able to plug in sensors to a cellular board, have it talking to the network quickly, and that was tough for me to find. Now there's some platforms out on the internet. Particle is a great example of that, but I wasn't interested in using their actual overall platform, the software side. I wanted to actually make something completely custom. And so, and this is both for myself and then also for my customers. So I wanted to have that as a thing that I could reuse over and over again. And so that's what I was set out to build. And so it turned into something like this, and it actually is a course that we show you how to build the whole thing online. So here was the 3D model back in July, and then we actually got the boards assembled, and here we are with the actual board here. So this is up close and personal with this thing. I also have it here in my hand. So I do have the board here. This is board 2A, which you'll see. So this is the front side. I label all my boards like this. And here's the back side. And I also have a broken out version. This was 1A. So the idea is to have it as an actual breakout. So the idea is it starts its life as a Raspberry Pi hat, and then it becomes a breakaway section. And the main idea here is that on the other side, on this side here, there is this expansion header and these mounting holes. And the idea is that we can make some breakout boards or daughter cards that plug into it, and then that's where the sensors go. So let's take a quick look at what that looks like here. So this is the most recent daughter card that we built, the ABCDCBA, which is the daughter card board assembly. But the idea is basically this has sensors. It only has parts on one board, on one side of the board rather, and then on the other side there is the mating connector. And the idea here is that it's got this very tightly coupled, very low profile connection between these two boards. And so when they're plugged together, basically this, and broken out rather, this would be a standalone platform or a standalone sensor widget out in the field that could then go and be talking over cellular to a tower and taking readings and sending them back over cellular to the internet. Now you might be wondering why Bluetooth in the first place. Well, two reasons. One is the Bluetooth part is just kind of an interesting add-on. It's great for bootloading, adding new stuff, having someone being able to walk up to the device and connect to it with a cell phone without having an actual internet connection. It allows it to work without cellular at all. So if there's a low cost kind of thing where you don't need to be piping data, it works like that. But the real thing is that in this case, the NRF52 that's on board is actually the main microcontroller that's doing everything. And so because cellular, even in a best case scenario, cellular is kind of high power. This is a Cat M1 modem, the one that's on here right now, the BG95. That is a low power for cellular modems, but ultimately a higher power than I want to deal with because it is basically a Linux system in there, right? So it's a Cortex A7, I believe, in there or something like that. But internal to the actual module that's on board, you can go and program that module yourself if you want to. It has sleep current, it has a sleep mode rather, it can do all that stuff. But I wanted to be able to monitor that without actually using the cellular modem and the cellular module rather, and I wanted to just use it as a modem. So in this case, the NRF52 is acting as the controller for all this stuff. If sensor is hooked up and it has a new reading, the NRF52 wakes up, takes that reading, stores it, and then every once in a while, maybe every 10 minutes, every 20 minutes, it wakes up the cellular modem and says, hey, send this data to the internet. And in that way, it actually gets to be an even lower power solution. And that's really the kind of thing that I'm looking for when it's out in the field. It's taking sensor data as needed, right? It might be every 10 seconds, it might be every minute, might be even faster than that, who knows. But the idea is that it's done in a very, very low power way using these optimized chips. The NRF52 is a Bluetooth chip that's optimized for super, super low power. And basically it wakes up, takes the reading, goes back to sleep. And that's kind of its job. And then only once in a while does it actually go and connect to the internet over the cellular connection. The BG95 also has GPS for when it needs to and that sort of thing. One other thing I'm excited about with this, obviously on the back side here, it has not just the SD card holder for doing memory and the SIM card holder over here for talking to the network. It also has a charge chip on here that allows it to work with cellular and works with, of course, yeah, the charge chip works with solar rather. And so it has an MPPT or maximum power point tracking algorithm on there, basically to be able to work with the solar panel and charge out in the field at the maximum amount of charge for the battery that's attached to it using a solar panel. And so that's another exciting thing there. So all these things kind of work in conjunction. The last piece is all the software that's written for this is written using Zephyr. It's meant to be so that's a real-time operating system. It's very, very flexible. It's an exciting new, relatively new real-time operating system, but also it has great integration. It's kind of like a Linux Lite kind of idea, and in that way, it allows you to pull in drivers. So as we make different daughter cards for this thing, some of the drivers are already integrated into Zephyr, and you can just kind of say, hey, use these pins, and it's off to the races. So that's a very exciting development as well. And all of this stuff is available. We actually go through all of getting started with Zephyr, getting started with the sensors and the cellular and all of this stuff in the course that is over on contextualelectronics.com. So I've talked about this for long enough now. You can go and check out the course page. There's some more info over there. Even without being a member, you can go and check out all of the different steps that we go through, all of the design steps. I filmed just about everything with this design. So as I was going through, as I was making decisions, second-guessing myself, doing the actual layout, redoing layout as needed, doing some modifications to try and get this board manufacturable, all of those things, that is all recorded. So if you're interested in following along and seeing how to make a cellular and Bluetooth module that can be reused over and over again, that's something that we have over at contextualelectronics.com, and we're not done yet. So we just got the board back for the daughter card board. The first daughter card board, we'll be writing code for that, integrating it, and then building other things as well, and actually making this a platform that can be out in the field and sensing things. So if you have any questions, you can always go over to our forum. Our forum is also free and open to all. That's forum.contextualelectronics.com, or you can continue to watch videos here on YouTube and see what else is coming from the Contextual Electronics course. That's all for now. Thanks for watching. We'll see you in the next video.